Hello children, from today we are going to start new chapter chemical thermodynamics. So according to this chapter, most of the physical and chemical reactions are accompanied by energy changes. So all the changes which can be physical or chemical are taking place with the change in energy. These energy changes takes place in the form of heat, light, work, etc. So in a process, the change of energy can be of different type, and mainly the change of energy in the form of heat, light, work, etc. And they are convertible into each other. So these energy changes are also quantitatively related to each other. Okay, students. So when a fuel like methane, cooking gas, or coal burns in air, the chemical energy stored by the molecules is released in the form of heat. So in this example, you can see that the chemical energy is converted in the form of heat energy. The chemical energy may also be used to do mechanical work as in engine or electrical work as in battery. So according to definition of the thermodynamics, that thermodynamics deals with the heat changes accompanying a physical or chemical reaction. It also deals with the different forms of energy and quantitative relationship between them. Okay, so thermodynamics, this term is made up of two terms, therms and dynamics. Dynamics, movement, therms, energy or heat. So therms means energy in the form of heat, but you know that energy can be in the form of heat energy, light energy, sound energy. Okay, so there are number of types of energy. So now we are including all these types of energy in thermodynamics. So interchange of one form of energy in the another form, and also a quantitative relationship between the different type of energy. These all things we study in thermodynamics. Okay, students. So simply we can say that thermodynamics is the branch of science which deals with the study of different forms of energy and the quantitative relationship between them. Okay, students. Then after this we will take some basic concepts of thermodynamics, and out of these basic concepts, the first is system. What is system? So system, the part of the universe which is under experimental study and whose properties are being measured, is called system. Okay, so the system is the part of universe which is under observation. So such part of the universe which is under observation, and or you can say that which we are going to study the energy change from the system to the outside or from the outside to the system. So that part of universe which is under observation is known as system. Okay, students. Then next is surroundings. So the part of universe excluding system is known as surrounding. Okay, so as you can see from this relationship, that universe is actually system plus surroundings. Okay, so system and surroundings both are the part of universe. Okay, so when we remove surroundings from universe, we get system. The surroundings may exchange energy and matter with the system. So on the basis of type of system, the surroundings are also of different types, and some surroundings are such types through which interchange of energy or interchange of matter or interchange of both of these two can take place. The system may be defined by physical boundaries such as beaker, test tube, etc., which contain a definite amount of one or more substances. Okay, so actual boundaries, like you can imagine a room as a system. So the walls of that room will be boundary of the system, and outside of the room will be surrounding, and inside will be system. Okay, so the system which we are taking as room, so room is differentiated with the help of walls from surrounding. So outside of the walls, a whole area is surrounding, and inside the wall is room, and these wall will be considered as boundaries. Okay, so boundaries are separating a system from its surrounding. Okay, students. Now, boundary is the real or imaginary surface which separates the system from the surroundings. Okay, the boundaries can be imaginary also. For example, if you are standing in a ground, and you suppose that up to a certain distance, you are supposing around you are standing here, and around you up to a certain distance you are supposing as a system. Okay, students, then after this imaginary line, the part of the universe will be surrounding. So this boundary in this condition is imaginary boundary. Okay, students, because you are surrounding in a ground, and you are imagining that up to this distance there is a system, and you are the part of this system. So after this distance, the area of the universe will be known as surrounding. Okay, so here you are having imaginary boundary for your system. Okay, students, then types of system. Next heading, types of system. So before the types of system, the systems are divided in two types: homogeneous and heterogeneous system. So homogeneous systems are the systems in which are uniform throughout, means which are made up of just one component. A homogeneous system consists of only one phase or only one component. It might be pure solid, pure liquid, or a solution, and a mixture of all gases are homogeneous systems. Okay, students, so homogeneous systems are the systems which are made up of one component only. For example, if you filled this beaker with glucose only, so the beaker is the system. Which type of system? Homogeneous, because it is having only glucose here. Okay, the next type of system is heterogeneous system. Heterogeneous system. So heterogeneous system are the systems which are made up of more than one component. For example, benzene and water together in a beaker. So such system will be known as heterogeneous system. Okay, students, water and CCl4. So mixture of these two will make a heterogeneous system. Okay, so not all the mixture are making heterogeneous systems, because alloys are homogeneous mixture. So alloys will make homogeneous system. The next heading is types of systems. The first is isolated system. Isolated system. So these are the system Isolated system, these are the system which cannot exchange matter and energy both with the surroundings. Okay, so these systems are having insulator boundary, the boundary which are made up of insulator substances. Okay, so due to these type of boundaries, the system cannot exchange heat or matter with the surrounding. So such system is known as isolated system. For example, if you are having hot water in a thermos flask, hot water in a thermos flask. So hot water in a thermos flask, then from this flask heat cannot move outside, and also vapors cannot move outside, and same way heat cannot come inside, or water vapors can inside. So when we keep hot water in a thermos flask, there will be no any exchange of heat or component with the surroundings. So such systems will be known as isolated system. Okay, students. Next is closed system. So closed systems are the systems through which only exchange of energy can take place, but not of matter. For example, tea or hot water which is kept in a closed beaker. So in a closed beaker, heat can be exchanged with the surrounding, but water cannot be exchanged. So such systems will be known as closed systems. Then open systems. Open systems are the systems through which exchange of both matter and energy can take place. Okay, for example, hot water kept in open beaker. So through this system, both water or matter and energy can be exchanged between the system and the surrounding. So such systems will be known as open system. Okay, students, thank you very much.